Hey, hello guys, welcome to Network Beats. This is Tangadurai, and in this video, we are going to see about BGP synchronization rule. So, in BGP synchronization rule is like it is not anymore in the current iOS release that we don't want to bother about. It was you have to bother about this rule when you are in early days, like in like 10 years 15 years ago. If you're working with BGP, then you should know about it, but still I'm just recording this video to make sure like we are understanding what is this BGP synchronization rule and how does it work. Okay, but still we are having this option whether to enable or to disable in our BGP routers. So basically by default, this is disabled in the iOS release which is greater than 15. If you want to enable it, then you have to do it manually for the iOS version greater than 15. But if you're using iOS version 12, then by default synchronization rule is enabled. Okay, before discussing about all these things, let's discuss first of all what is synchronization rule. Synchronization rule is something that, okay, uh, here, okay, fine. Let's say uh, in router 5 I have a loopback configured, which is, let's say, 55.55.55.55, which is /32, and I'm going to advertise that to my R3, and R3 will be advertising that to R4. Okay, and how it is going to happen in normal with normal BGP, I'll be going under the router 5 BGP router BGP 35, and I'll be using the network command to advertise 55.55.55.55, and I'll be giving the mask 255.255.255, which is /32. Once I issue that command, then router 5 will be advertising my 55.55.55 prefix to R3 and over to R4. Not only to R3, it is going to also advertise to R2, and through AS500 through R6, R4 is going to receive that. Okay, but in this lab, I will be shutting this link, and we will be concentrating only from R5 to R3 and R3 to R4. Okay, so BGP synchronization rule says that, okay, uh, router 3 is running BGP 35, right? Now I am advertising 55 prefix over BGP to R3, right? Until unless this 55 network, right? 55.55.55.55, until unless this particular prefix is learned uh, through BGP. Okay, it is okay. I'm advertising this over the BGP, but also R3 would expect to learn 55 network through IGP as well. Okay, let's say I'm using IGP EIGRP, let's say 35 in this network to have the connectivity between R3 and R5. I have to also learn this through via EIGRP. Then only I am authorized to advertise 55.55.55.55 to R4. Okay. If it is only learning via BGP, R3 is not going to advertise, but also it has to learn 55.55.55 through EHRP as well. I have taken EHRP an example for IGP. You can run DRIP, OSPF, ISIS, it is up to your choice. Okay, so what synchronization rule says that if a router is learning a prefix through BGP, okay, it is not enough. That particular prefix has also to be learned via IGP protocol. It can be anything, EIGRP, OSPF, WIP, or ISIS. It can be any IGP protocol, but it has to learn as well as in IGP protocol. Then only that particular router can advertise that particular prefix to the other router. Okay, so here let's what we are going to do in this lab setup is we have already 55.55.55 is configured, that loopback is configured on R5. Okay, I'll be shut down this link because I don't want to interrupt the services, because this will be confusing for us. Just purely we are going to understand how this prefix is going to advertised, to R4 through R3. And I have told, I'm using I'll show you the version what I'm using. In my version the synchronization is disabled, enabled by default. Synchronization is disabled by default. We'll be enabling that and we'll be checking the behavior of the BGP synchronization. Let's go to terminal and let's see what is the version that I am currently running. Show version. I'm using version 15.2. So here BGP synchronization is disabled by default. So in order to so if I want, I have to enable it manually. Fine. So let's go to R5. Let's see what happened here. Show IP interface brief. Pipeline include up. Here already I have the loopback 55.55.55 is configured, and let me go to R4 and check whether I'm receiving that first of all. Yes, okay, I'm receiving through AS 500, which is through router 6. Okay, so first what I'll do, let me go to R5 and let me shut fast ethernet 0/0 so that my prefixes, okay, first of all my neighborship will go down and whatever the prefixes that I'm sending, everything will be erased in all these routers routing table. So now router 4 will not be seeing that 55.55.55. Let us clear the BGP, clear IP, BGP store soft. Still I'm seeing 55 is learned. Let's go and see what is happening here. Okay, show IP interface brief. Okay, also down. Okay, this I already have made admin down. It is not supposed to receive that. Let me go to R6, clear IP BGP store soft. Okay, whether it is receiving 55. Let me also do the same, clear IP BGP store soft. Show IP BGP. Still I'm seeing that. Let me hard reset it. Okay, it is gone now. Also R should not be seeing that. Okay, it is gone in R4. Okay, so this is the problem with the BGP. Actually it takes more time for the convergence. Okay, because BGP is a slow protocol, uh, so it takes time for convergence. So but we cannot go and do the hard reset in the production environment. So that's fine. Now we are not receiving 55 on R4 uh, because our objective is like we are going to advertise this 55 prefix over this particular direction through R3. So in order to do that, what I'm going to do first, okay, so let me uh, go to R3 and I'll show you the configuration of my BGP. Show run pipeline section.bgp. Same, I'll do it for R5 before continuing any configuration. and also I'm just verifying I'm not receiving that. Okay, R5. Okay, so this is the configuration that I have. I am advertising that network 55 with a mask of /32. That's good. Okay, what about R3? Okay, I have R3 here. Also, you are not seeing anything related to synchronization, right? There is no keyword called synchronization. And after that, what happens here is show IP BGP summary. Okay, my session is idle here. Okay, I don't know why. Let's see. Okay, because currently there is no connectivity between this. I have just removed the static route which we have configured in the previous video, because here we are going to just enable EIGRP protocol like we have told in the start of this video. So what I'll do here, let me just create a EIGRP process 35, and I'm going to advertise my 35 network. Before that, let me just give new auto summary network 35.0.0.0.0.0.255, and also I'm going to advertise 5.5.5.5 and network 55.55.55.55. This I'm not going to advertise now. Okay, I'm just advertising 35 and my 555 loopback IP address. Let me go to R3 and also enable show IP BGP summary. Okay, so my BGP neighborship with R5 is idle here because I don't have any connectivity to show to R5's loopback IP address. Show IP route 5.5.5.5. Network is not in the table. What I'll do, router EIGRP 35, and I'm just enabling auto summary and network 35.0.0.0.0.0.255, and that's it. And here mine also, let me advertise 3.3.3.3. Okay, that's it. Now we will be seeing our neighborship is up. In R5, I think we have the route to 3.3.3.3. That is why, yeah, that is a static route. That is why even before configuring this particular command, we were seeing the neighborship is coming up. That's fine, not an issue. Okay, so if you go to R4 and see, okay, we will be learning 55. Why? Because it is a normal behavior, right? Because as of now synchronization is not enabled on router 3, router 5. So router 5 is advertising 5.5.5.5 and 55.55.55 prefixes to R3, and R3 is advertising to R4. Okay, but what we have discussed about the synchronization tool is, okay, whatever the prefixes are advertised by R5 to R3 over BGP, it has to also learn via EIGRP. Okay, then only it is going to advertise that to R4. Otherwise, it is not going to advertise it to R4. So, in current scenario, R5 is advertising what? Two prefixes, right? One is 5.5.5.5. Another thing is 55.55.55.55. Okay. Let me match only 55 prefix. So what I'll do, okay, it is sending via what, BGP, right? And also I have to send this. Before that, let me just go and enable the synchronization on R3. Let's see that how to enable that. Configure terminal router BGP 35, right? And I'm just enabling synchronization and hit enter. That's it. Now synchronization is enabled on R3, and let me clear both EIGRP neighbors and clear IP BGP 4.4.4.4. Okay, so let's go to R4 and check its BGP table. As of now, it is only learning 4 network and a 5 network. Okay, why 5 network is learning? Okay, because it is also coming from R5. The thing, okay, here uh, we have advertised 5 network in EIGRP in order to provide the connectivity between R3 and R5 to make the IBGP up between R3 and R5. Because of that, we have advertised 5.5.5. Since it is also advertised in BGP and also it is learning via EIGRP on R3, R3 is allowed to advertise 5.5.5 to R4, but it is not advertising 5.5.5.5. Why? Because this 5.5.5 is only advertised on BGP. It was not advertised through EIGRP, right? Once it is also learned via EIGRP, then R3 will be advertising 5.5.5.5 as well to R4. Let's go and see what is happening over there. Okay, and I'll just show you the configuration again. Show run pipeline section router EIGRP. Okay, here under EIGRP we are advertising 5.5.5. Okay, and also section BGP. Okay, it is taking some time, please hold. Okay, in BGP also we are advertising 5.5.5. Okay, let's go to R3 and see show IP BGP, its BGP table. It is learning a 5.5.5.5, but what is this R? We have discussed in our previous video. R is something called RIP failure, because already R3 has this particular route in its routing table with better AD value, right? Comparatively the BGP, because it is learning via IBGP. By default, IBGP AD value is 200, and it is already learning it via EIGRP. EIGRP AD value is 90, so 90 is lesser than 200. So EIGRP route is more preferred than the IBGP route. Let's go and verify that. Show IP route EIGRP. So 5.5.5 is learning via EIGRP. D means dual, okay, which is used by EIGRP protocol, and its AD value is 90. So that is the reason it is using this particular update over EIGRP rather than BGP. So that's fine. Show IP BGP neighbor 3.3.3.3. Sorry, I am on router 3, so my neighbor is 5.5.5.5. Routes. That means what are the routes that I am receiving from 5? Okay, I am receiving 5.5.5.5, and also I am receiving 55.55.55, right? You are saying 5.5.5 is the valid path, but it is not the best path because it is learning via EIGRP. Comparatively, the BGP EIGRP is the best path, but this 55 is valid, but it is not the best. Why? Because in R3 we have enabled synchronization, so it is just learning only via BGP but not through EIGRP. So because of that reason, this is not best path. So since it is not the best path, it is not getting installed in the routing table. Okay, if you see in BGP, okay, there is nothing is there. Show IP route, I'll just show you the complete routing table. You are just seeing 5, which is learning via AHRP, but not 55. Because of that, this is not marked as a best path. And keep remember, only the best path, okay, that is going to only advertise to the BGP neighbors, not all the paths, whichever it is there in the BGP table. Whichever the best path that BGP is seeing in the routing table, only that will be advertised. So because of that reason, it is not advertised to R4. If you go to R4, show IP BGP neighbor 3.3.3.3 routes. So only this is the route that I am receiving from R3. Okay, and if let's go and see which are the routes that R3 is advertising to R4. Show IP BGP neighbor 4.4.4.4 advertised routes. So this command shows us what are the routes that R3 is advertising to R4. So it is advertising only 5.5.5. Okay, and again, why 5.5.5 is advertised? Why? Because there is RIP failure here, but still it is the best path. Why? Because 5.5.5 is still in the routing table, right? Which is learn via EIGRP, right? Because of the best path, it is already available in the routing table. BGP is allowed to advertise this particular prefix. And why it is not advertised? It is a valid path, but still it is not a best path. Why? Because we have enabled synchronization and it is only learning via BGP, but it is not learning via EIGRP, which is our IGP protocol here. Once it is also learning via IGP protocol, then this will be advertised to our R4. So in order to do that, what we will do, let's go to R4, sorry, R5. Okay, and in R5, what I'm going to do, I'm also advertise router EIGRP 35, and I'm also advertise 55 network through EIGRP, so that router 3 will be receiving, okay, show IP BGP. So router 3 will be receiving, okay, before, if you see here in show IP BGP, we were seeing it was star means it is a valid path. If it greater than symbol is there, then it is the best path. It is not the best path. That is why we are not seeing this symbol like 5. Okay, but after advertising that through the EIGRP, now it is not the best path. It is RIP failure here, because routing table has the best path comparatively the BGP route, because it is also learning via EIGRP like we have told before. But now it is the best path. Why? Because it is not only learning through BGP, but also it is learning via EIGRP. Now this is valid to advertise to R4. Okay, let's go and verify what it is advertising now to R4. So previously it was advertising only 5 network to R4, but this time it is going to advertise 55 as well. See here. So we are seeing both now, right? So let's go to R4 and verify whether he is receiving 55. Yeah, he's also receiving that. Let's try ping and check whether it is working or not. 55.55.55 and source loopback 0. Yeah, it is not working. I know what is the issue here, because in our previous configuration that we have forgot to put next stop self command here. Okay, so let me just show you. Otherwise, it is not going to work, because R5 doesn't know who is the next hop to reach R4. Then R4 is because of that reason, R5 is not able to. R4 will be sending the echo echo request, but R5 doesn't know how to reach R4 to send the echo reply. Because if you go to R5 and see show IP route 4.4.4.4, it is not in the network table, right? Show IP BGP, okay. It is there in the BGP table, but it is not the best. Why? Because the next hop 4.4.4 I'm not having in my routing table. I don't know how to reach the next hop IP. So because of that, I'm keeping it as a valid, but it is not the best uh, prefix to use. So I'm not going to install that in my routing table. So how we can resolve this? Go to R3. Okay, here section router BGP. Here in router 3, let's wait. Okay, now we got that. Okay, in router 3 what okay, this is the thing. Okay, with router 5 I'm not seeing any next hop self. Okay, because it is the edge router for this particular AS35. In all the edge router, whichever the update is going inside the AS, obviously we have to make change for the next hop attribute. If you have seen my previous videos where I have explained this very clearly, uh, if you have not watched that, please go and watch that in order to know about the next hop self, how does it work. So here what I'm going to do, router BGP35, and here my neighbor is neighbor 5.5.5.5, and here it is next hop self. Similarly, I have to do it on router 5, which I missed to do it in last video. Let me also do that. Router, for this video it doesn't make sense by configuring that in router 5, but still for our future use I don't want to face any issue on this router 5, so just I'm enabling it here as well. 3.3.3.3 next job self. Okay, what happened? In router 5 neighbor 3.3. Okay, I know what is the reason here. Because if you see here, section router BGP, in router 5, basically for this particular neighbor, we have configured a peer group, right? If you remember, I'll show you here. But here what I have done, I have tried to specify something manually apart from which is not defined in the peer group. You cannot have, uh, let's say here, this is a peer group that I have configured. Okay, this is a peer group that I have called for the neighbor 3.3.3.3. Now what I am trying to do here, I am trying to make one new entry, say stating neighbor 3.3.3.3 next hop self. Okay, you cannot have multiple entries for neighbor 3.3.3.3 when you are using the peer group. Whatever you want to define the properties, you have to do under the peer group. Okay, so this is why it is giving me error. Okay, that I cannot execute this command, which so let me go and define this in the peer group. So router BGP 35 neighbor peer group next hop self. Okay, oh, I'm sorry. Okay, that's it, because already it is called under the neighbor. So I'm done now. Let me go to router 5, show IP BGP. Let's see. Now, before it was not a best path, now it is a best path because next hop is changed to 3.3.3.3. Previously it was 4.4.4.4 because I have changed the next hop self on router 3. Because of that, router 3 is changing the next hop as its own self, router 3's IP address. So now we can able to, previously we were not able to ping, because of that now we should able to ping. So this is what the synchronization tool, just a recap. Okay, let me just, what is synchronization tool? When a router is advertising a prefix over the BGP, that particular prefix has to be learned also over the IGP protocol. Okay, if it is not learning through IGP, this particular router is not going to advertise that particular prefix to R4 until unless the prefixes are learning via both BGP and IGP protocol. So this is what the synchronization rule is, and if you want to disable that, how to do that? Just you can go to router BGP 35 and type no synchronization. So this disables the synchronization rule. So you don't want to, that means this rule is not applicable when you have disabled this. Thanks for watching. Have a good day. Bye.